In the last lesson, you learned about square roots, and there are other types of roots other than square roots. There are all different number of roots, and the next level is something called cube roots. And so question that I have for you is what number multiplied by itself and then multiplied by itself one more time, so 3 times, what number gives you 27? If you said 3, you are correct. Unlike the last note sheet, -3 doesn't work because -3 times -3 is +9, and then 9 times -3 is -27. So cube roots don't have 2 answers like square roots do. Anytime you have an even root, it's going to be positive and negative, and the odd ones are going to be just one answer. But this number, like I said, is called a cube root because when you use it as a factor 3 times, you get the original number. Similar to a perfect square, there are things called perfect cubes, and that's when you have an integer as your answer. Almost all numbers have cube roots. It's just a question of how complex they are. So numbers that have an integer as their answer are going to be called perfect cubes. And similar to the square root, you see this symbol right here, it looks almost like a square root symbol, but it's got a 3 inside. And when you have the 3 in between that little check mark symbol, not in front, it has to be in between. It can't be here. It has to be squeezed right in that little check mark. And that's the symbol for cube root. So let's look at some examples. In the first one, before we go to the examples, you might have a symbol if you want to. You should have your calculator. If you grab your calculator, you may or may not see a symbol that looks like this. We're going to just do it with guess and check. And then when I see you in class, I'll walk around and look at all your calculators to help you find how you can do the cube root on your calculator. If you don't have it, then you're just going to end up having to do guess and check. But chances are, if you have a scientific calculator, there is some key on there for you. So, all right, so now let's get to the examples. What the letter A is asking is what number, when you use it as a factor 3 times, gives you 8? So what times what times what equals 8? I want to use that same number 3 times. So let's do some guess and check. What number do you think it is? The answer is 2, because 2 times 2 times 2 is 8. So the cube root is 2. Over in example B, what number used 3 times gives you -27? Well, we already looked up earlier in the example that 3 gave us +27. So let's see what happens with -3. -3 times -3 is 9, and 9 times -3 is -27. So the answer to this is -3. Just like we did yesterday, or in the last lesson, I want to split up this square root, or this cube root, and find out what number cubed is equal to 1, and what number cubed is equal to 64. Well, 1 is the cube root of 1, because 1 times 1 times 1 is 1. And do a little guess and check to figure out what number equals 64. The answer is 4. So that's going to be, the answer is 1/4. We're going to just incorporate our PEMDAS to do some of these. So I wrote PEMDAS, and then I'll squeeze a little r for PEMDAS. So first thing I have to do is that radical. So let's look here. What is the cube root of -216? What number used 3 times is -216? It's 6, or -6. So this becomes 2 times -6, because when you have a number next to a symbol, it's multiplication. So the answer to this is negative 12. In letter B, you want to figure out, we got to do the parentheses first. So what number used 3 times is 125? Guess and check, you should get 5. And so the answer is that we're going to put in the parentheses is 5. And then we have to do the rest of it, which was raising it to the third power. 5 times 5 times 5 is 125. And so cube roots are the inverses of cubes. And this is just like the last lesson where square roots were the inverses of squares. Cube roots and cubes, or third power, inverse each other. I'd like you to pause the video and try examples 1, 2, 3, 4, and 5 on your own. Before we go to the next examples, I just want to talk about a couple of notes that I would like to bring up. These right here, if you don't have to do these, you don't have to do them. Don't do all of this. I'm just doing this to show you how I'm getting the answer. But everything that I just crossed out in green, you don't ever have to write down. If you can do it in your head or on your calculator, then just write it down. It's not necessary. The other thing that I want to point out is in number 3, remember there was a negative here, and I've always told you that when you have a negative in front, it always just goes to the top. Well, really, you could put it with either one, but most people just put it with the top number, but it does not apply to both. So it would just be negative 27, not both negative. And then over here, we had to follow order of operations. And over here, you could just cancel these out and put negative 64 if you realized from the other example that they eliminate each other, but I went through the extra step. In these examples, we're going to be doing the same thing that we did in example 2, only first we have to plug in the number. So I'll plug in 192. And now I have to follow order of operations. So the first thing that I'll end up doing is the radical. And in order to do the radical, I have to simplify this fraction underneath. So 192 divided by 3 is 64. So now I bring everything else down. The cube root of 64, I just learned from the other question, is 4. And I'll do this division while I'm here. That is 48. 48 plus 4 is 52. Over in letter B, same thing. I'm just going to plug in negative 3. And when I go here, everything is under the square root or the cube root symbol. So I don't have parentheses or exponent. Well, the parentheses just mean multiplication. So I will go straight to the radical, and I will get the cube root of negative 27, bring everything else down. Cube root of negative 27 from the other example is negative 3. And I'll do this multiplication while I'm here. It's negative 6 minus negative 3. I just brought down that minus sign. And that is negative 3 as a final answer. Example 4, find the surface area of the baseball display case. And they give us the volume. So couple of formulas. The volume of a rectangular prism is length times width times height. And the surface area, I'll put it down here separate, is 6 times side squared. So you find the area of one side, multiply it by 6. But which formula, because that's what they wanted. They want surface area, but they've given me volume. So I'm going to plug in what I know. I know from the picture that the volume is 125. And I know that the S is the same on all 3 sides. So really what they're asking me is, what number to the third power is 125, right? What times what times what is 125? So using some trial and error, that means that the side length has to be 5, because 5 times 5 times 5 equals 125. And I'll show you, if you have the feature on your calculator, how to get this. So the side length is 5, but that's not what they want. This is a big mistake that a lot of kids make, is that once they get something equals, they assume that they're done. The question wants the surface area, so we have to plug 5 into this formula. 6 times 5 squared. So that's 6 times 25. So the surface area is 150 inches. Since it's area, it's squared. All right, write down any questions that you have, and we'll do some more examples when I see you next.